Okay, so the next feature that is still in a more rather experimental phase, but that's nevertheless really interesting feature, and we are working on this as we speak, is to essentially allow users to run IPv6 only Kubernetes clusters, and the main goal is to still being able to interact with like more legacy workloads for IPv4. So for example, if they have external services which are maybe connected somewhere else over the internet and they only have IPv4, then we want to provide like a mechanism for the user to be able to connect to them even though the whole cluster is running on IPv6 only. So I'm like in the slides that I have prepared here, I'm doing a walkthrough in terms of how this looks feature-wise for traffic that goes into the cluster, and then the second part is covering traffic that is going out of the cluster. So what you can see here on the right side is a Kubernetes cluster which is IPv6 only, and on the left side is, let's say, some nodes on the internet. For example, a client can be user or some other node that is trying to connect into the IPv6 only cluster. And for this, from an architectural high-level view, essentially the translation with NAT4 to 6 looks like this: that the external node is doing a request, for example, to foo.com, some domain. The DNS server is responding with an A record to say that the given node is on this IP address, and then the external node is doing a, let's say, if it is a TCP connection, a SYN request, and it's directed towards that NAT4 to 6 gateway. And the idea here is that this is like a small layer at the edge of the cluster. So while the actual Kubernetes cluster is IPv6 only, this small layer here is a dual stack one where it runs Cilium in a standalone load balancer mode, which is a mode that we developed. And it handles those requests that are coming in for this particular VIP, for example. So it has a translation table, and it will then do the address family translation. So from 4 to an IPv6 address. And the idea here is that as the IPv6 address, you can, for example, enter the service VIP under IPv6. So let's assume, for example, inside that Kubernetes cluster, a particular service was exposed as a load balancer service, and under that given service VIP here, then that node here in the middle, that NAT46 node, will then translate the original request to the IPv6 VIP, and then it will be directed into the cluster. And then the cluster, like as Kubernetes natively is doing with for example, with Cilium's kubeproxy replacement in eBPF, it will then handle the service and be able to translate it to one of the backends. So that can look like this, right? So if you're a Cilium user, you can see, you can debug the output from like the state of Cilium in terms of services. So you can see that Kubernetes installed a regular IPv6 service with IPv6 backends. But the idea is essentially to direct from one VIP that is IPv4 to another VIP that is IPv6, and then that is a more stable IP, so that node only needs to direct things to a VIP and not to backends themselves, but then the whole service is managed inside the Kubernetes cluster as usual. So that's the one area. And the second idea of this architecture would look like this. On the left side, we now have our Kubernetes IPv6 only cluster. And on the right side, we have, let's say, the IPv4 world or the internet, or, now the question is, how can IPv6 only nodes talk to the outside world. If, for example, their services or like their applications consume external, services from external workloads, for example, right? So in order to be able to communicate, we would need NAT6 to 4 translation. So then, of course, the question is, if like a given node from the Kubernetes cluster wants to talk to an IPv4 address to the outside world, how does it get there? And it can get there by doing DNS requests. So if it tries to connect to, let's say, bar.com, then there's a DNS 6 to 4 proxy here. So that's the idea. And that proxy is essentially redirecting the DNS request to the actual DNS server that is somewhere in the internet. And that replies with an A record with the IP address where this specific node is reachable. And then that proxy here that is at the edge of the cluster is essentially translating this IPv4 reply back to nodes that are inside the Kubernetes cluster as an IPv6 response with an AAA record with a specific prefix. So that's like an RFC prefix, which is in particular dedicated for v4 and v6 addresses for the wire, and it has the actual original IPv4 address as part of the IPv6 address. So this whole thing here is an IPv6 address in total. And yeah, so then the IPv6 only cluster has something to talk to in IPv6, and it can send out its SYN request. And then again, we have this gateway, and this time in the other direction in the NAT6 to 4. And that gateway is essentially translating the address family again from IPv6, this time to IPv4, and it's just stripping off the prefix from IPv6 that has been given, and the IPv4 destination address is already available in the packet, and it has to do NAT, which means in this case the source address will be the address of this gateway for IPv4, and yeah, it's storing the original request in its local connection tracking table. So then it can send out, once it translated to the IPv4 packet, it can send out the SYN request to the actual external node. And yeah, that will reply with the SYN ACK. In case of TCP, for example, it will go back to this NAT64 gateway, and it's doing everything in reverse again. And it's replying to the node inside the cluster. So this is the way how we can make this work. And again, this component is also handled through Cilium. The DNS 6 to 4. So there's software available, and one example here that can do this today already is Core DNS. So there are some URL where you can get information and also how to configure this. So you can, as a user, you can specify the prefix that it should reply with, whether it's the standard one or like a custom one, and yeah, so that's available as well. And yeah, so this is the architectural overview in general. So with those components, this can be achieved. In the case of Cilium, what the piece that we are working on is essentially this gateway, where you have the NAT46 and 6 to 4 translation. That's very interesting because if you look at the Linux kernel with the regular, more traditional components, such as, for example, netfilter, IP tables, IPVS, there has never been a component which can actually translate in the kernel this NAT46 or 6 to 4. So traditionally, the way this has been done was either through like an out-of-tree kernel module, because maybe it was limited and it has never been upstreamed because of that. Inside the kernel, the data structures around the packet, they contain a lot of information, and it's actually really hard to do this to do this translation there. And so that's why it never got it natively. The other option would have been in a more traditional sense to push this somewhere up to user space, and then do the translation in user space, but that's also not really efficient. So the way we do it in Cilium is essentially through eBPF. And there are two cases. So like one is that we attach to the XDP layer, which is basically where Cilium pushes a program down into the driver layer. And the other one in the TC BPF layer, which is a bit higher up in the stack. But for eBPF, we provided some minimal helpers which do the translation for the in-kernel data structure, like some minimal metadata that needs to be translated, but the rest is done through native eBPF code in Cilium. And to show you a demo, I'm showing essentially this piece of the whole puzzle. And yeah, so what you can see here is I have a Cilium, an instance of Cilium running. It's running in the load balancer in an LB only mode. It's a data path mode where this can be installed as a standalone load balancer. And if you go and check out the Cilium status. Oh, okay. So the agent is up, and if you now check out the Cilium status, what you will see is that there's a NAT46 and NAT64 support here that is enabled. Oops. In the standalone load balancer, you can program this through an API, but there's also a CLI available where you can install services and backends. We usually use this for debugging. So the typical way is to use the API in a programmable way. The CLI in here is doing this internally. So you can, for example, install a front end and a back end. And yeah, I'll just clear the screen. This will be better in terms of visibility. What you can see here is that we installed a IPv4 service web, and there's an external IPv6 web. Just for the sake of the example here, this is going to Facebook actually. And if I have another node in the cluster that is connecting, that is basically pushing traffic to the service web to this node, then the actual request will be translated to IPv6 underneath. So that's something we're going to take a look at now. So I have a second node, same network. We're doing a request. What you can see here, curl is giving us some data. And if you look at the TCP dump, like the packets, how they look on the wire, it's actually interesting to see that that was my client. It has a given address and port, and it's connecting to the service here. That's the service. It's a TCP, so you can see the SYN packet. And that load balancer node that is running Cilium in here in BPF, it's translating this to an IPv6 packet, that original request. So you can see here, that's the IPv6 source address, and that's the actual backend address that we just had up here. And it's still the SYN, but it's now sending this out to the external node. And in our case, this particular one here, if you go back to this architecture description, would be the VIP that is inside our Kubernetes IPv6 only cluster that would be the service WIP there. So it's basically forwarding this request. So that's essentially what we are simulating. And then on the way back, you can see that the remote node replied. The packet is coming back to the node, and then we are doing everything in reverse again. And the node where we just executed our curl is essentially getting the reply from the service WIP. So yeah, so that's the direction when we have an IPv4 WIP, so that essentially external clients can connect from somewhere from the internet into the cluster, so that we provide this IPv4 entry point, and then we can redirect this to an IPv6 only cluster, and we can still talk through it. The other way around also works. So I added a second one in here. So we have now what we're looking at is basically the case where a node in the cluster, in the IPv6 only cluster, wants to talk to a service that is somewhere external in the internet. So that this address is basically the connection point for the IPv6 node to do the NAT64. And then we will translate this into an IPv4 request. So again, if we're doing if we check how this looks on the wire, and we're doing the curl. What you can see here is that we got a reply, this time from Cloudflare, actually, because that's the DNS address. And what you can see here on the load balancer node is that we received a client address in IPv6 that is connecting to the service that we, to the thing that we exposed here. This is doing a SYN request because it's TCP, of course. And we translate this whole request to an IPv4 request, so that we change we're doing the source NAT to the NAT of that gateway node, and the destination to the actual backend that we programmed, and we get the reply back. And then everything is also being done in reverse, so that the other node can only see this IPv6 request. Yeah, so that's pretty much awesome. It for the demo.
Cool. And there were a couple of questions in the chat, but I also wanted to ask you about availability of these features.
So we are so this standalone load balancer with the NAT46 and NAT64 that is already available with Cilium 112. Let me quickly share my screen. So we released that essentially here. There's some information that can be found.
I'll put the link shortly.
Yeah. The one thing that we are working on right now is that going back to the slide, that we can basically do like this whole wildcard prefix translation, so that you don't need individual entries, but you can just have one, and then this is just being forwarded. But yeah, that shouldn't take too much, given most of the infrastructure that we implemented is already in the code with the latest Cilium release. So my the expectation would be like that we ship this with 1.13 release.
Just a couple of more questions in the chat. Hans asks, is there an option to translate the IPv4 source to an IPv6 mapped IPv4 source? I think that's
the IPv4 source to an IPv6, so like into an IPv4 in IPv6 mapped. So that can be added as well. Yeah. So right now it's not there. I think that would tie in pretty much into what I just mentioned here, given it's just the same thing, just in reverse. So yeah, that's what we are going to add still.
Okay. I think the question is from Radek is similar. Also, it's Radek is asking about. So right now we're doing one-to-one mapping, and yeah, could we map from a whole prefix?
Yeah, exactly.
So
yeah.
Okay. So that's a work in progress. But
yeah, no, definitely. So yeah, like the infrastructure for this is in our code, and that's the next step. That's why I mentioned earlier on that's an experimental thing that we are working on right now, and so that's just like a really early preview. But yeah, that's going to come.
Fantastic.